In this video, we will discuss Greibach normal form. Greibach normal form is used to prove the equivalence between push-down automata and context-free grammars. Now, GNF is also used for parsing purpose. In compiler designing, when we do the parsing, then the grammar should be in Greibach normal form, right? So, what is Greibach normal form? It is that every context-free language without epsilon can be generated by the context-free grammar with the rules A tends to A, B1, B2 up to Bm, and A tends to A. Means at the left hand side we have single non-terminal, at the right hand side we have a terminal followed by non-terminals, right? Means at the right hand side we must have the first symbol must be a terminal symbol, and the second rule is at the left hand side we have a non-terminal and at the right hand side we have a terminal symbol. So these type of rules are permissible in Greibach normal form, where A, B1, B2 up to Bn belong to non-terminals and A is a terminal symbol. Now let's take an example here. Convert the following grammar into Greibach normal form. To convert any grammar into Greibach normal form, there are 5 steps. Let's see all these steps one by one. The first step is, as we did in Chomsky normal form, for every terminal symbol introduce a non-terminal symbol. So here, suppose we are introducing capital A for small a and capital B for small b, and when we replace the values, then this rule will become this, right? Here we have replaced this, not replaced, we have introduced capital A for small a and we have introduced capital B non-terminal for small b. Now the grammar will become like this. Now, second step. In second step, introduce an ordering among non-terminals by renaming them. Renaming them means we rename all the non-terminals. So here we have 3 non-terminals, S, A and B. So we rename all the non-terminals starting with S, then we are having a rule with A, and after that we are having rule B. So A1 name is given to S, A2 is given to A and A3 is given to B. So we have renamed all the non-terminals. Now apply these names to the rules. Now the rules will become of the form, earlier we had rule of the form S tends to SS. So this rule has become A1 tends to A1 A1. Next rule has become A1 tends to, see the earlier rule we had S tends to A S B. Now the rule has become A1 tends to A2 A1 A3. Similarly, this was S tends to A B. Now it has become A1 tends to A2 A3. Okay, and this was A tends to A. Now it has become A2 tends to A, and this was B tends to B. Now it has become A3 tends to B. Now come to step 3. In step 3, look at step 2. Here we are having this A tends to A1. A1 is the left recursive rule, cause A1 is occurring at the left hand side of the entire string, right? So in step 3 we remove left recursive rules, if any, right? Here we are having only one left recursive rule. Now, according to the removal of left recursion procedure, if we have a rule of the form A tends to A alpha and A tends to beta, then what do we do for each A tends to A alpha? See, we can have number of rules of left recursion, and we can have rules non-left recursion. We can have number of rules which are non-left recursion. So that's why we are using this I. So for each I of the form A tends to A alpha I, we introduce these two rules, Z tends to alpha I and Z tends to alpha I Z. And for each non-left recursive rule, we introduce these two rules, A tends to beta I and A tends to beta I Z. Now look at these rules. Here we are having A1 tends to A1 A1. This is left recursive rule, right? And we have A1 tends to beta. Here beta is representing A2 A1 A3, right? We have A tends to A alpha, or we have A tends to beta 1, A tends to beta 2. These two rules are non-left recursive rule, and this rule is left recursive rule, right? So here A1 tends to A1 A1. Here this is alpha, this is alpha, and beta 1 is A2 A1 A3 is beta 1 and beta 2 is A2 A3. Now according to these rules, right? So for these rules, A tends to A1. When we apply this A tends to A1, and after converting these rules, we will be having A1 tends to A2 A1 A3 and A tends to A2 A1 A3. This is the rules for A tends to beta, right? This is the beta 1. We have beta 1 here. This is beta 1. So these two rules are for A tends to beta I. Here we have A1 tends to this is, and A1 tends to this Z. Again beta 2 we have A2 A3. So these rules will be A1 tends to this beta and A1 tends to beta Z, right? For left recursive rules, we have these two rules. Here we have A tends to A alpha. See, look at this rule. A1 tends to A1 alpha. When we remove the left recursion, then the rules will become Z tends to alpha. Here alpha is A1, right? So it will become Z tends to alpha and Z tends to alpha Z, where alpha is A1. So the rule is Z tends to A1 and Z tends to A1 Z. And these are the previous rule we are having in the grammar. Now after step 3, all the rules are having, see, in this step all these rules are having of the form either in Greibach normal form, or we have some Z rules, or we have these type of rules where the subscript I and J, where J is greater than I. See, here we have A1, we have A2, A1, A2, A1, A2. In every rule, suppose if it is J and it is I, in every rule J is greater than I. Now at the end of step 3, all the rules will be either in GNF or in this form. AI tends to AJ gamma where J is greater than I. Fine. Now after this we have step 4. In step 4 we convert all the AI rules to GNF. Then for this what do? We start from AN and proceed to A1. Now A1 is the highest subscript. Here we have A3. The value of I, the highest value of I is 3. So A3 tends to B. So and A2 tends to A. Then we will use these value and we put these values into other rules. Like A3 is here. Okay. Like now at the end of step 4 we may have some useless symbols. If we have some useless symbol, then we need to remove those useless symbols. In this case we are not having any useless symbol, right? So here what I have done, A tends to, earlier we had A2, A1, A3. So we have used the value of A2. Similarly, in this rule, earlier it was A2, A3. Here also we have used the value of A2. Similarly with this and this, right? Now we have converted all the AI rules to GNF. Now all these rules are in GNF except these two rules. Now in step 5 we convert all the Z rules. In Z rule we are having A1 here. Now the value of A1 will be substituted here. Now in place of Z tends to A1, all the A1 rules will be replaced here. Now after substituting the values of A1, then we get following rules. Z tends to A1, Z tends to A1Z. So we replace all the Z rules, right? After replacing all the Z rules, we get these rules, all these rules. Now here we have 8 rules, 8 Z rules are there. In these rules, rule number 3 and rule number 5 are same. See, A1, A3Z and A1, A3Z. Similarly, rule number 4 and rule number 6 are same. Then what do? We remove rule number 5 and 6. Right? So we remove these two rules. After removing these two rules and after adding these Z rules to the previous rule, then the final grammar will be this. All these A rules and Z rules. Now the grammar has been converted into Greibach normal form. All the rules are there in the Greibach normal form, where at the left hand side we have single non-terminal, and at the right hand side either we have terminal symbols or a terminal symbol followed by a string of terminals and non-terminals, right? In each rule we have a terminal followed by a string of non-terminal symbols. Let's take one more example. S tends to AA, S tends to A. Next rule is S tends to SS and S tends to B. Here A is useless symbol. See, A is not deriving any terminal string. So A is useless symbol. So we remove the rule S tends to AA. After removing this, we have this S tends to SS and S tends to AB. Now look at this. We need to convert this grammar into Greibach normal form, right? So the first step is that for each terminal symbol, introduce a new non-terminal symbol. But look at this rule. We do not have any terminal symbol here, right? So if we do not have any terminal symbol in this case, then we do not need step 1, right? Start with step 2. Introduce an order among the non-terminals, means rename all the non-terminals. Suppose A1 is representing S. Here we have only single non-terminal, right? So A1 is representing S. Now the rule will become A tends to A1, A1, A1 tends to A, and A1 tends to B. Here again we have A tends to A1, A1 is the left recursive rule. Now come to step 3. We need to remove this left recursive rule. We have single rule here. Now this is left recursive rule and these are non-left recursive rules. So this is of the form A tends to A alpha and these are of the form A tends to beta 1, A tends to beta 2, right? So convert these rules. A tends to A alpha, so this rule will be converted into these two following rules. Z tends to alpha, where alpha is this A1. So the rules will become Z tends to alpha and Z tends to alpha Z. For these two rules, A1 tends to A, we have A1 tends to A and A1 tends to Z. Second is A1 tends to B. Then we will be having A1 tends to B and A1 tends to BZ. Now come to step 4. Now what is step 4 here? Step 4 is that convert all the AI rules, right? But in this case all the rules are there in GNF only, so we do not need to convert AI rules. That means step 4 is not required. We have only Z rules. Now the fifth step is required. Now come to step 5. We have all the rules. A tends to something. Now we will convert these Z rules. A tends to A1 and Z tends to A1 and Z tends to A1Z. Now we will replace the value of AI in Z. Now after replacing all the values of A, then we have following Z rules, right? We are having 8 Z rules again. Now in this, rule number 2 and rule number 5, Z tends to AZ, and rule number 5, Z tends to AZ, both are same. Similarly, rule number 4 and 7, Z tends to BZ and Z tends to BZ are same. So what we do? We remove one of these rules, right? So rule number 5 and rule number 7 will be removed. So finally we have this grammar in GNF. See, all the rules are in the form of GNF only.